Good morning. It is Wednesday, May 20th. Today we are going to solve word problems using x plus y equals and using elimination methods. So the math is what we did yesterday with the elimination method. We're going to now solve word problems where the first equation is going to almost always be x plus y equals. So here are the notes. The notes are the same as yesterday's lesson. As you can see at the bottom, for word problems, the first equation is just x plus y equals for an amount. The second equation is usually a money equation, but not necessarily. And then if we're talking about money, a penny is worth 0.01 times the amount of pennies, because pennies 1 cent. A nickel is 0.05 times the amount of nickels. A dime is 0.10 times the amount of dimes. And quarters are 0.25 times the amount of quarters. So when we see money, that's how we deal with that. But again, the first equation is almost just x plus y equals, as long as you know that. This is pretty straightforward, and this is a very big topic in Algebra 1. So, Alicia, let's get my pen, and let's get this blown up. Alicia purchased H half gallons of ice cream for $3.50 each and P packages of ice cream for $2.50 each. She purchased 14 items and spent $43. Which system of equations could be used to determine how many of each item she purchased? So again, there's two equations. The first one is almost always just x plus y equals. We have items and we have money. So let's start with items. Items, she bought half gallons of ice cream. She bought packages of cones. So my x plus y equals in this case isn't x and y, it's h and p, and h and p equals the total number of items, which is 14. There's no money in this equation, it's just the amount of items. Again, your first equation is almost always just x plus y equals. Now my money equation. How much are all the half gallons of ice cream going to cost? Well, they're going to cost $3.50 times the number of half gallons that are bought. The total cost of the cones is going to be $2.50 times however many packages of those, and the total cost is $43. So which choice has that? It looks like choice 1 is that. H plus P equals 14, 350H plus 250P equals 43. Perfect. So again, it's pretty straightforward as long as you understand that your first equation is going to almost always just be the two variables x plus y equals. Number 2, the Celluloid Cinema sold 150 tickets to a movie. Some of these tickets were child and some were adults. A child ticket cost $7.75. An adult cost $10.25. If the cinema sold $14.70 worth of tickets, blah blah blah. So two equations, one for the tickets, one for the money. Let's start with the tickets. Again, the first equation is almost always just x plus y equals. So in this case, it's a plus c equals 150. There's no money in this equation. It's the amount of adult tickets plus the amount of children's tickets equals the total number of tickets. Now the money equation. Well, a child ticket costs $7.75, an adult ticket costs $10.25. So it's $10.25 times the amount of adult tickets plus $7.75 times the total number of children's tickets equals the total money, which is $14.70. Looks like again we have choice 1. Again, the first equation is almost always just x plus y equals. That's your total number of whatever the items are. And then if you have a money equation, you're putting the money in front of each variable. Why don't you try number 3 on your own right now? I'll give you about a minute. Okay, Lizzie has 30 coins, a total 480. So there's going to be two equations, one for the coins, one for the money. Let's start with the coins. She has dimes and quarters. So your first equation is almost always x plus y equals. In this case, it's d plus q. The dimes and the quarters must add to equal the total number of coins, which is 30. There's no money in this equation. It's just the items. It's the number of coins. Now, the money equation, the value of the dimes and the quarters. Well, dimes are 10 cents each. So the value from the dimes is 0.10 times the number of dimes. Let's just erase that and rewrite that a little bit neater. So again, the value from the dimes is 0.10 times the number of dimes. The value of the quarters is 0.25 times the total number of quarters. And the total value of these coins is 480. Finally, we get one that isn't choice 1. It looks like this one is choice 2. So again, your first equation is almost x plus y equals. That's the total number of items. There's no money involved in that one. In the money equation, then I'm putting the value of each in front of each variable. And my right-hand side, of course, will be the total money. So now here's one where they actually want us to solve. Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. So I've got total number of items and I've got money. So I'm going to make two separate equations. Let's start with the items without the money. And again, as a hint, it's almost always x plus y equals. So I want you to come up with the first equation on your own. I'll give you about 15 seconds to do that. My first equation, apples and peaches, apples plus peaches equals 165. No money involved in that equation, just the total number of pounds of apples plus pounds of peaches is 165. Now for my money equation, the apples were 175 per pound, the peaches were 250 per pound, and it cost a total of 337.50. I'll give you about 10 to 15 seconds to come up with that equation on your own. $175A plus 250P. This is the money equation, and the total money is 337.50. That's my system. Now it wants me to solve the system. It wants to know how many pounds of peaches did she sell. So now this goes back to what we did yesterday. Normally I say pick a variable to cancel. We could take a little shortcut here. Since I want to know peaches, I want to get my A's to cancel. So multiply each equation by the other's coefficient. 1 goes on bottom, 175 goes on top. Are the signs the same or different? They're both positive. They're the same. That's bad. So I make one of them negative. I multiply everything through. Negative 1.75a minus 1.75p equals negative 1.75 times 165. I'm using my calculator for that. Negative 288.75. The bottom one I'm just multiplying by 1, so nothing's changing. I add them together. My A's cancel. I get 0.75p equals, I'm going to use my calculator for the next part, 48.75. Divide by 0.75. P equals 65. So how many pounds of peaches were sold? 65 pounds of peaches. Now, if it wanted me to also find the number of apples, I would then just substitute into one of the original equations. It'd be easier to do the items one, not the money one. A plus 65 equals 165, and A would be 100. Now again, it's not asking me for that in this particular problem, but if I needed to find both variables, then we just finish the procedure that we talked about yesterday. And that's really all there is to it. I will go through one more with you, although I feel like at this point I don't need to. Again, you set up the system with an items equation, which is almost always just x plus y equals. Then a money equation, where you're putting the value in front of each of the variables. Once you have your system, if you want to solve it, you use the elimination method that we talked about yesterday. But let's just take a look at one more. Why not? Do we want to do apples and oranges, the candles, the math department? Let's do one with the money. So, number 8, Byron has 72 coins in his piggy bank. The piggy bank contains only dimes and quarters. He has 1470 in his piggy bank. So I have the total number of coins. I have total value. You're going to have to create two separate equations to represent the situation. I would use D for dimes and Q for quarters. You can use X and Y, whatever you want. I'm going to give you about a minute or so just to set up your system. So again, you have about a minute to set up your system. Okay, for my total number of coins, there's 72 coins. So we have dimes and quarters. D plus Q equals 72. Now for my money equation, dimes are worth 10 cents, so it's 0.10 times D for the value of the dimes. Quarters are 25 cents, 0.25 times Q for the value of the quarters, and the total value is 1470. Now that I have my system set up, I can solve it. It's asking for how many dimes, so it would be easiest to get the quarters to cancel. One's on top for the quarter, so one goes on bottom. 0.25 goes on top. Are the signs the same or different? They're the same, so I have to make one of them negative. So I multiply everything through. I get negative 0.25D minus 0.25Q equals, I'm going to use my calculator for that, even though I could probably figure it out on my own. Negative 18. The other one is not going to change, so I'm multiplying by 1. And as you can see, when I add them together, my Q's are going to cancel. I'm left with negative 0.15D equals negative 3.3. Divide by negative 0.15. D equals, use my calculator, 22. It's asking for the number of dimes, so my answer is 22 dimes. If I wanted to find the number of quarters now, I could just sub in D plus Q equals 72. 22 plus Q equals 72. And Q is 50. So again, this is a very important Algebra 1 lesson, and again, it's a very important SAT lesson. They love to ask these questions. You need to be prepared for it, and it should be an easy question to get correct if you practice it. So I know this lesson is a little bit on the long side, so I'm going to give you 2 days for it. Your classwork / homework is to, and this is for Wednesday, and Thursday is to finish the worksheet, and your quiz will be due Sunday. So again, to solve these word problems, you need to start by setting up your system. It's almost always x plus y equals for the first equation for the amount. The second equation is usually a money equation. You're just putting the value of each variable in front. And then to solve it, you're using your elimination method, which we went over in the previous lesson. Any questions, reach out to me and remind, and have yourselves a great day.